Okay, folks, let's go ahead and get started for today. So what we have been doing is we have discussed the process of calculating the formula mass. Oh. We have talked about how the formula mass differs from the molar mass and how to calculate the molar mass. The difference between these is the quantity of items we're talking about, whether we're talking about a single unit or an entire mole of units. We have talked about Avogadro's number. I hate when it does that. Oh. And we have talked about mole to mole ratios from the balanced chemical equation. So on Monday, we specifically talked about formula mass and molar mass and calculating those. In so doing, I introduced Avogadro's number. On Wednesday, we used the formula mass to go between grams and moles. I should say, excuse me, the molar mass to go between grams and moles. We used Avogadro's number when we were talking about atoms, ions, or molecules, and we used mole-to-mole ratio in order to go between two substances. So that is actually quite important, is knowing when to use what. Again, this allows you to convert when you have mass involved. So that's what you're looking for, is mass. If you got mass involved, you want molar mass. If you see the word molecules, ions, or atoms, that is telling you that you're going to be using Avogadro's number as your conversion factor. And the other one, if you have two different substances, that is when you're going to use the mole-to-mole ratio. So we did a problem where we used just the molar mass as a conversion factor on Wednesday. We did one problem where we just used the Avogadro's number as a conversion factor on Wednesday. And we did one problem where we just used the mole-to-mole ratio as a conversion factor on Wednesday. Today, what we're going to do is we're going to expand on that. So let's look at some problems. How many atoms of oxygen are in 3.216 grams of oxygen? So when we were doing this, one of the first things I said to do is identify what you were given. In this case, we were given 3.216 grams of oxygen. You were asked for atoms of oxygen. And now we ask, so that was the process. Then we were going through and trying to determine conversion factors. The first one was, is it the same substance? In this particular case, it is the same substance. So no mole-to-mole is required. The second thing we did is we would look at the starting unit. And we started out with grams, which is a unit of mass. So we need the molar mass. According to the equation, or according to the periodic table, for every 16.00 grams of oxygen, that is equal to 1 mole of oxygen. That is its molar mass based off the periodic table. Then we looked at our ending unit. Our ending unit is that of atoms. Because we are dealing with the word atoms, you need Avogadro's number. Which is 6.022 times 10 to the 23rd of anything. In this case, oxygen atoms is equal to 1 mole of that thing. In this case, oxygen. Now we're ready to start the conversion. We start with the piece of information given, which was the 3.216 grams of oxygen. Our first conversion factor needs grams of oxygen because we need to make sure that we can cancel out the grams of oxygen. So we're going to use our molar mass first. And we're going to put the 16.00 grams of oxygen in the denominator and the 1 mole of oxygen in the numerator. The grams of oxygen were placed in the denominator so that the unit and the substance would cancel, leaving moles of oxygen. But we were not asked for moles of oxygen. We were asked for the atoms of oxygen. So we need a second conversion factor. In this case, it's going to be the third one, which is our Avogadro's number. Of Avogadro's number, the mole portion is going to go in the denominator with the 6.022 times 10 to the 23rd in the numerator. Again, that mole portion went in the denominator so that the unit and the substance would cancel out, leaving atoms of oxygen. Since you have what you want to solve for, now you can key it all into the calculator. And you get an answer of 1.210 times 10 to the 23rd oxygen atoms. Just so you know how I keyed this into the calculator, it would have been 3.216 times 1 technically divided by 16.00 times, and if you're doing it the way most people do it, it's open parentheses 6.022 times 10 caret 23 close parentheses, technically divide by 1, and that should give you your answer. Now I will say the way I actually keyed it in was 3.216 divided by 16 times 6.022. And then I used my second comma, technically, 23. And what that looks like on the calculator is 3.216 divided by 16 times 6.022 E23. So 2 different ways you can key it into your calculator. Questions about this problem? Folks, the answer is usually only 1 or 2 points. How you set it up is worth the majority of the credit. So if you are struggling with your calculator, you can still get a significant portion of the credit by showing your work and me seeing how you're setting up the problem. Yes.
So yesterday I asked about the little number like the 23. So that wouldn't change in this problem. Like yesterday you changed it to 26.
The math came out to 26 or 25, whatever it was. So when I did the math, it changed the superscript.
So like it'll show it in the calculator.
Yes. Yes. Let's look at another problem. What mass of argon contains 1.203 times 10 to the 26 argon atoms? I identify what I was given, which is 1.203 times 10 to the 26 argon atoms. I identify what I want to solve for. I want mass of argon, which means I want grams of argon. First things first, the starting material and the ending material are the exact same. So there's no need for a mole to mole ratio. The next thing I notice is my starting unit was that of atoms. Atoms means we will need Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd of anything, in this case, argon atoms, is equal to 1 mole of argon in this case. The next thing I notice is that the unit I want is grams. grams means molar mass. Argon has a molar mass of 39.95 according to the periodic table. Now that I have the conversion factors, I'm ready to start the problem. I'll start with the 1.203 times 10 to the 26 argon atoms. The first conversion factor I need is going to contain argon atoms. So I'm going to need to use Avogadro's number. The argon atoms portion is going to go into the denominator with the mole in the numerator. The atom portion had to go in the denominator so that the unit and the substance will cancel out. That leaves me moles of argon, but if you look back at the question, I don't want moles of argon, I want mass of argon. So that means I'm gonna need a second conversion factor, in this case, the molar mass. Of the molar mass, the mole portion will go in the denominator with the mass portion into the numerator. The mole portion had to go in the denominator so that the unit and the substance would cancel, and you were left with mass. Now we're ready to key it into the calculator. And we get an answer of, 7,981 grams of argon. Now, as far as how to key it into the calculator, again, you do have two choices. One choice is that you can do it as 1.203 times 10 caret 26 in parentheses divided by 6.022 times 10 caret 23 in parentheses times 39.95. Or you can key it in as 1.203 second, comma, 26, divide 6.022 times 10 to the 20, excuse me, second, comma, 23 times 39.95. If you do it the latter way, it will look like 1.203 little e 26 divide 6.022 little e 23 times 39.95. Take, again, the difference between these two, folks, is The second one, if you forget a parentheses, you're still okay, whereas the first one, if you forget a parentheses, you may not be okay. Yes.
I'm not sure if I have this within law, but I got 8,000.
Right off the top of my head, I wonder if your calculator set up to have unlimited digits, or if you've got it set to a certain number of significant digits. That's where I would go, because 7,980 does round to 8,000. So I have a feeling it may be how it's set up in your calculator as far as how many digits it will allow. I'm gonna stop doing the showing you how to key it into the calculator. These are the examples that you can go back to though. But I wanted to at least show it to you a couple of times so that you have an example. The rest of it I'll still be doing. Okay, so let's do another one. What mass of oxygen is in (290) or 2.93, excuse me, 2.93 times 10 to the 24th aluminum oxide molecules? Start by identifying what you were given. We were given 2.93 times 10 to the 24 aluminum oxide molecules. Identify what you're looking for. We are looking for mass of oxygen. And then we start figuring out our conversion factors. Aluminum oxide and oxygen. So the first thing I note is there are two different substances. So a mole to mole ratio will be required. In this case, the mole to mole ratio is that there are 3 moles of oxygen in every 1 mole of aluminum oxide. The 3 coming from the subscript. The next thing I notice is that I was given the term molecules. Molecules means Avogadro's number is required. That number being 6.022 times 10 to the 23rd. In this case, Al2O3 molecules is equal to 1 mole of that material, in this case, Al2O3. The third thing I notice is I need grams of oxygen. Grams of oxygen. Grams means molar mass is needed. According to this, according to the periodic table I have here, again, I'm using a different one than what's on the board. 16.00 grams of oxygen is equal to 1 mole of oxygen. You always have to use whatever periodic table you're given. Now that I've broken it down, it's ready, time to do some math. You start with what you were given. In this case, that will be the (2.93) times 10 to the 24 Al2O3 molecules. Your first conversion factor needs Al2O3 molecules, so we will be using number 2 first. Of that equality, the 6.022 times 10 to the 23rd Al2O3 molecules goes in the denominator with the 1 mole of Al2O3 in the numerator. The Al2O3 molecules had to go in the denominator so that the unit and the substance would cancel, in this case, leaving you moles. But you weren't asked for moles of Al2O3, so you're not done yet. You need a conversion factor that allows you to go from Al2O3 to oxygen. So we're going to be using our first one. For every 1 mole of Al2O3, there are 3 moles of oxygen. The mole portion of, or the mole of Al2O3 went in the denominator so that the unit and the substance would cancel, leaving moles of oxygen. But we weren't asked for moles of oxygen. We were asked for mass of oxygen. So we need a third conversion factor. So we're going to use the third one in this case to go to grams of oxygen. The mole portion has to go in the denominator with the gram portion into the numerator. The mole portion is placed in the denominator so that the unit and the substance will cancel, and you are left with grams of oxygen, because that's what you were asked to solve for. You're ready to key it into the calculator. And when you key this into the calculator, you will get 234 grams of oxygen. as your answer. Yes.
Okay, so how come you ain't cancel out? So you did the first cancellation for the molecules. How come you cancel out all of the first?
The what? Now, one more time?
So when you did the cancellations for the AL203, you canceled out the whole numbers, like the entire thing. How can you do the same thing for the one molecule?
I didn't cancel out the number. All I did was cancel out the words. That's the unit and the substance. I didn't cancel out the 1 or the 6.022 times 10 to the 23rd or the 3 or the. I'm only canceling out the unit and the substance. Think I see what you're talking about, and I just got overzealous. It shouldn't have I shouldn't have scratched out a number. Any questions about that one? Let me give you one to work on. Trying to make sure I'm not duplicating. What mass of nickel 2 sulfate contains 2.62 times 10 to the 22 sulfur atoms? And while you're working, I want to remind you that you not only have a homework due on Sunday night, but you have 2 math chemistry tutorials that are due that you've got to go through your Blackboard shell into this week's folder to get to. Yes.
You add all those, substances, well, elements, what you do.
To get to that 157? Yes.
How can you do that? And this, like, how do you know when you need to add and when you don't? That's wrong.
If I'm just asking for an atom, then I won't need to add anything. Because the masses on the periodic table are for one atom. Or 1 mole of atoms. But if I'm working with a substance, then you got to add them up. So the fact that there was more than one element is the reason I had to add them all up. So looking at the question here, the first thing I noticed is that I was dealing with 2 different substances. It is for that reason that I knew that I was going to need the mole to mole ratio at some point. The next thing I noticed is that I was working with atoms. And because I was working with atoms, that is what told me I was going to need Avogadro's number. And the last thing I noticed is that I needed mass. And because I needed mass, that is the reason that I needed the molar mass. In each case, I chose what went in the denominator by what I needed to cancel out. And the other portion automatically had to go in the numerator. And when you key this into the calculator, you got 6.73 grams of nickel 2 sulfate as an answer. Yes.
Okay, so back to the 154.7. What is that?
It is one, so what I added is the fact that I had 1 nickel at 58.7 grams. I had 1 sulfur at 32 grams. And I had 4 oxygens at 16 grams each.
Does that for
That would be 64, 32, and 58.7. For a total of 154.7. Yes.
Okay, I don't know if he asked it or if I didn't hear it. So how do you know to do the 154.7 instead of like just doing like the S? Like on the last one we did the just for oxygen.
Because of what I'm asking, what it is you want the mass of. In the last one, I wanted the mass of just oxygen.
Okay.
In this one, I wanted the mass of the entire compound. So it's all dependent upon what it's asking for, what that grams is associated with. If it's associated with just an atom of an element, it's just an atom. If it's associated with a compound, then it's the molar mass of the compound. Any other questions? That's time.